Good morning, everybody. This is Ms. Hazel S. Matthias from the Department of Mathematics, KLS Vishwanath Rao Deshpande Institute of Technology, Haliyar. In the previous class, we were discussing about Fourier transforms. We have discussed about what do you mean by Fourier transforms, how to find the Fourier transform, and how to evaluate a given integral using inverse Fourier transform. As well as we have discussed about Fourier sine and Fourier cosine transforms as well. Mainly Fourier transform, what it does is it's an image processing tool which helps us to convert an image or a wave into its sine and cosine components. So that is the main application of Fourier transforms. It's an image processing tool which converts an image into its respective sine and cosine transforms. So that's regarding sine transforms. In today's class, let's discuss about Z transforms. So the introduction, I'll tell you all what is it and what are its uses. So like we have discussed about Laplace transforms and Fourier transforms in our previous classes. From the definition of Laplace and Fourier transform, we can say that it's a definite integral, correct? Laplace transform and Fourier transform, they are represented in terms of definite integrals, where the integrand is involved with the two parameters. In Laplace transforms, we used to have S, H, and here we used to have, say, Fourier transform definition, which varies from minus infinity to plus infinity, f of x cos ux dx. U is there, x is there. We used to have two parameters. But the resulting integral which should consist of a single parameter, isn't it? Even though we used to have two parameters in the definition of Laplace and Fourier transform, we used to have two parameters in the definition of Laplace and Fourier transform, say u and x and h in Laplace transforms. But the resulting integral, we used to always get it in terms of a single parameter. But here, Z transform operates on the sequences of functions of a single variable. What it deals with? It deals with the sequences of functions of a single variable. It is defined for non-negative integral values of that variable. Okay, it deals with the non-negative integral values, and this transform has number of properties which are similar to that of Laplace transforms. So you can relate Laplace transform to this Z transforms. The main use of this Z transform is to solve the difference equations. Okay, difference equations, we will learn this at the end. This is the application part. Laplace transforms are mainly used to solve the difference equations, where these difference equations arises in situations where we are using the data, and the data consisting of a set of values of unknown functions. Suppose if we have a data which consists of set of values of an unknown function, we will have the difference equations, and using Z transforms we will be solving those difference equations. Now, just as Laplace transforms and Fourier transforms, the Z transform also serve as a tool to solve some types of ordinary differential equation, partial differential equations, and also Z transform serves as a tool to solve difference equations. So main application of the Z transform is to solve the difference equation, but it also solves some kind of ordinary and partial differential equations. So these are the applications of Z transform. Now how Z transform is defined, let's discuss. So Z transforms, the definition of from the Z transform. Z transforms. So suppose if we have a function, say un is equal to f of n, which is defined for all values of n, positive values 1, 2, 3, etc. and un equal to 0 for n less than 0. It is defined as f of n for all the positive values, and un will become 0 for all the negative values. So Z transform is defined for all the positive values. So the Z transform is usually denoted by Zt of un. Remember, this is denoted as Zt of un. And it is given in terms of summation n equal to 0 to infinity un z power minus n. What I said about Z transform, it operates with the sequences of functions of a single variable. You have a single variable, but it deals with the sequences of functions. So if you can expand, you will get different functions for n equal to 0, 1, 2, etc. up to infinity. So this is how the Z transform is defined as. So say there's this series, we'll take this as 1, and this series converges. Okay, whenever the series on the right hand side of 1 converges, it will be a function of Z. Suppose if the term on the right hand side of equation 1 converges, then it will be a function of Z, and we will write it as of un equal to, we will write it as zt of un equal to u bar of z. So this is the definition of z transform, and this term on the right hand side converges, then it will be a function of z, and we can denote it as zt of un equal to u bar of z. Suppose if it converges, series converges means it will be closer and closer to some value, and if it converges, it will be a function of z, that we will mention it as u bar of z. Okay, if zt of un equal to u bar of s, let's take this as 2, and this zt of un equal to u bar of s, we can write it in terms of its inverse. That is, what will be zt inverse of u bar of z? Zt inverse of u bar of z is un, and this is known as inverse z transform. This is known as inverse z transform. This is known as inverse Z transform. I hope this is clear. Z transform is represented as a sequence of functions of a single variable of function, and if the right hand side of one converges, then it will be a function of z, then that's why we can write it as zt of un equal to u bar of z, because it will be a function of z. Then inverse transform is defined as zt inverse of u bar of z equal to un. This is the inverse z transform. So we will be learning to find the Z transform as well as the inverse Z transform. How we have defined Laplace transform and its properties, and there are some we have learned about some standard Laplace transforms. I hope you all remember. Likewise, we have here standard Z transforms as well. That one we need to remember. You can completely relate this to Laplace transforms, how we used to solve using some standard Laplace transforms. Here also we have some standard Z transforms. So let's discuss one by one about that. Similarly, here you do not have the proof of those Z transforms. You just need to remember that. Okay? Is it okay, everyone? Are you all listening to me?
Yes, ma'am.
Okay, fine. Let's continue. So we'll discuss about standard Z transforms. Okay, so first one is Z transform of k power n. Suppose if we may have to use this. What is a Z transform of k power n? So I'll just derive this and show you all, but it is not required from your exam point of view. You just need to remember what is a Z transform of k power n. So we will apply the formula of Z transform, that is summation n equal to 0 to infinity, and it can be written as k power n z power minus n, because Z transform of, here we have Z transform of un is summation n equal to 0 to infinity un z power minus n. But here we have k power 0 to infinity k power n z power minus n, and we can write it as summation n equal to 0 to infinity. I'll write it as k by z power n, correct? K power n into z power minus n is kz. Okay, here this z power minus n I can write it as how? 1 by z power n. So it will be k power n by z power n, which is k by z power n. And now expand that. Give different values for n. When it is 0, something power 0 is 1. When n equal to 1, we will get k by z. When n equal to 2, we get k by z whole square plus etc. It continues, and this will be a geometric series, correct? This is a geometric series. This is a geometric series which is of the form 1 plus r square plus etc. And what is the sum of this geometric series? Sum of geometric series is given by 1 divided by 1 minus r. Here what is r? What is the common difference? Here r is k divided by z. R is k by z. We have got a geometric series which is of the form 1 plus r square, whose sum to infinity is given by 1 minus r, where r is k by z. So you can substitute that as zt of k power n, that is equal to the sum of the series is 1 by 1 minus r, where r is k by z. So simplify this. Here when you take the LCM, it will be z divided by z minus k. So you need to remember this. What is zt of kn? Zt of kn is z by z minus k. You just need to remember this. So whenever in the problem we may have to use what is the z transform of k power n, it is z divided by z minus k. Okay, remember this. You can write down. Next we will discuss about what is the z transform of 1. What is the z transform of 1? Simply we can do what here is, we can put k equal to 1. Okay, in the previous one, say zt of k power n, that is equal to z by z minus k. So if we put k equal to 1, okay, what will be 1 power n? 1 power n will be 1. So what will be zt of 1? K is 1, so it is nothing but z by z minus 1. So zt of 1 is z by z minus 1. Is it okay, everyone? Yes? Megha, is it okay?
Yes, ma'am.
Nandita, is it okay? Nikita, Parvati, Prajwal?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Okay. So let's continue. So you need to remember this. What is that transform of k power n? It is z by z minus k. Z transform of 1 is z by z minus 1. So let's discuss the third standard z transform, that is zt of n. Okay, zt of n. So if you compare this with the previous one, okay, zt of n. Now you may have here, what you can do over here is, we will take the case when k equal to 1. Okay, when k equal to 1, what happens? What is the transform of n? Okay, what is the transform of n when k equal to 1? How you can solve this? How can you solve this? Anybody, any idea how to solve this one? Anybody tell me how can we solve this one? Just think about it for a while. How can we find this? How to solve this one? Anybody? How can we find z transform of n? Anyone? Okay, so before we find the z transform of n, there is one property that you need to remember. Okay, the property is that, remember this, this is a note. This is a note. There is one property which says that z transform of n power k, z transform of n power k equal to minus z into d by dz of n power k minus 1. Write down this, okay, where k is a positive integer. K is a positive integer. There is a property which says that Z transform of n power k equal to minus z into d by dz of n power k minus 1. So in order to find this now, see, compare this with this one now. We need to find the Z transform of n. Z transform of n. When you compare this with this one, k is 1 over here. Am I correct? Okay, this is the standard property you need to remember. This is the standard property we need to remember. We need to find Z transform of n now, where k is equal to 1. So how it gets transformed now? How it will get transformed now? Zt of n, where k is 1. So what is Zt of n? That will be minus z into d by dz of k is 1. So it will be n power 1 minus 1. Correct? Am I correct? Yes. Kavya, is it correct? Parvati, is it correct?
Yes, ma'am.
Okay, so n power 0. Anything power 0 is what? Sorry, here it is Z transform is missing. It will be Z transform. What is n power 0? It will be Z transform of anything power 0 is 1. And what is Z transform of 1? We have discussed just now. Correct? Z transform of 1 is Z by Z minus 1. So this will be minus Z into d by dz of Z transform of 1 is Z by Z minus 1. Differentiate this. Differentiating, what do we get? Minus Z into, it will be U by V rule. So denominator square, then denominator into differentiation of Z. It is 1 because we are differentiating with respect to Z, minus Z into differentiation of Z minus 1 is also 1. So we have over here Z minus 1 minus Z. So it will become, what happens over here? Just check what happens over here. On simplification, what do we get? Plus Z and minus Z. Plus Z and minus Z can get cancels. Here we have minus 1. Correct? Minus 1 remains and here is minus Z. So it will become Z divided by Z minus 1 whole square. So what is Z transform of n? Z transform of n is Z divided by Z minus 1 whole square. What property we have used? We have used Z transform of n power k is equal to minus Z into d by dz of Z transform of n power k minus 1, where k equal to 1. So when we substitute that, we get Z transform of n is equal to Z divided by Z minus 1 whole square. Is it okay, everyone? Is it okay? Shall we continue? Anybody, any doubt? Anybody wants to ask anything? Basavraj, any doubt? No? Okay, let's move on to the next one. Now, just now what we have found out Z transform of n. So you can write it one by one. You just need to remember this. You need not know the formula. So you need not know the proof of it. So next one we will find fourth one, Z transform of n square. So similarly we will apply that rule, property. What is that property? What is that property? Z transform of n power k, zt of n power k, that is equal to minus z into d by dz of z transform of n power k minus 1. So here k will be what? When you compare this with this one, here k is equal to 2. So what will be zt of n square? It will be minus z into d by dz of zt of n power k minus 1. So it will be n power k. K is 2 minus 1. So what do we get over here? Minus z into d by dz of zt of n power 2 minus 1, which is n. And we have found out here zt of n. What is zt of n? Z by z minus 1 whole square. So substitute over here. On substituting we get d by dz of zt of n is z by z minus 1 whole square. Am I correct? Anybody has any doubt? Anybody, any doubt? Apeksha, Kavya, Mazin, Nandita, Nikita, any doubt? Okay, so now let's differentiate this u by v rule. It will be denominator square. So z minus 1 whole square will be z minus 1 whole power 4. Then we have new denominator z minus 1 whole square into differentiation of numerator. Differentiation of z with respect to z is 1 minus difference z into numerator into differentiation of denominator, that will be 2 into z minus 1 into differentiation of z minus 1 is what we get. Differentiate using u by v rule. We all know how to solve that, how to differentiate using u by v rule. That is, denominator is the denominator square, so it will be power 4. Then denominator into differentiation of numerator, differentiation of z is 1 minus z into differentiation of z minus 1 whole square is 2 times z minus 1, and differentiation of z minus 1 is 1. Now let's solve this. What do we get while solving this one? So you can see this z minus 1 is a common term from both the terms, so you can take that outside. So if you take z minus 1 outside, what remains? Just check. We will have, if I take 1z minus 1 out from here, 1z minus 1 remains minus, here 2z remains, minus 2z divided by z minus 1 whole power 4. Now next, see, you can cancel out 1 minus 1 from here. What happens when you cancel out 1z minus 1? It will be z minus 2z will be minus z, correct? Z minus 2z is minus z minus 1 divided by z minus 1 whole cube. Am I correct? Yes or no? Anybody, any doubt? Anybody, any doubt? Now next what we do here is, I'll take minus 1 out from this. So if I take minus outside, minus of minus will become plus z, z into z plus 1 divided by z minus 1 whole cube. So it will be z square plus z divided by z minus 1 whole cube. So this is what z transform of n square. Is it okay, everyone? Is it okay? Nikita, Parvati, Rajwal.
Yes.
Okay. So we have found out z transform of n. Then we found z transform of n square. Now next, see, these are the standard forms you need to remember. Always. This should be there. Or else you need to derive like this and check. So next we will find the z transform of n cube. We'll find the z transform of n cube. So similar property, zt of n power k, that is equal to minus z into d by dz of z transform of n power k minus 1. So here k is what? Here k equal to 3. So z transform of n cube is nothing but minus z into d by dz of z transform of n power 3 minus 1, that is n square. So that is minus z into d by dz of z transform of n square. We have proved over here z transform of n square is z square plus z divided by z minus 1 whole cube. Now differentiate this. On differentiating, so what do we get over here? Transform of n cube is minus z into, here you see what happens, it's denominator square, so z minus 1 whole cube square will be 3 into 2, so it is 6. So we will have z, the denominator into differentiation of numerator, differentiation of z square plus z. What is the differentiation of z square plus z? It is 2z plus 1, so we get 2z plus 1. Then minus numerator, numerator is z square plus z into differentiation of denominator, differentiation of 1 whole cube, that is 3 into z minus 1 whole square into differentiation of z minus 1, which is 1. So we get 3 into z minus 1 whole square. So this is what we get after what? What is this? After Am I correct? Anybody any doubt? Anybody any doubt? Please answer.
No, ma'am.
Okay. Then continue. What do we get after continuing here? Just continue. What do we get? So similarly, we can take here see z minus 1 whole square. You can take outside z minus 1 whole square. So if I take z minus 1 whole square, what remains over here? Just check what remains over here. It is z minus 1 into 2z plus 1. So similarly over here minus from here I can write this as z square plus z minus 1 whole square I have taken into 3 divided by z minus 1 whole power 6. Am I correct? Next, see here, you can cancel out one term over here. So what remains? Minus z into, you simplify this over here, z into 2z, it will be 2z square, correct? Z into 2z, it will be 2z square, z into 1 is z, then minus 1 into 2z is minus 2z, minus 1 into plus 1 will be minus 1. Then similarly over here, it will be minus 3z square minus 3z divided by z minus 1 whole power 6. Now simplify this and write what happens here is minus z into 2z square minus 3z square is minus z square, then z minus 2z is minus 2 minus z minus z minus 3z, it will be minus 4z, then we have minus 1 over here divided by z minus 1 whole power 4 because we have cancelled it is 4 because we have cancelled out 2 over here. So 6 minus 2 it will be 4. So this is what we get it. Now again simplify, you can take the minus sign outside. So if I take minus sign outside, minus into minus will become plus, then multiply with z, we get z cube plus 4z square plus z divided by z minus 1 whole power 4. This is what? This is the transform of n cube. Is it okay, everyone? You need to remember this. Okay? Is it okay? Okay. Let's discuss the next thing we have over here. That is the properties we have. Certain properties of Z transforms we will be discussing. So first one is the linearity property. Okay, let's discuss about linearity property. Linearity property of Z transforms. Linearity property of Z transforms. So what is that? It is very simple. Suppose if we have Z transform of Cn Un plus C2 Vn. Z transform of C1 U1 plus C2 Vn. It can be written as C1 into Z transform of Un plus C2 into Z transform of Vn. Okay, what is where C1 and C2 are constants. So this is the first property, that is linearity property. Z transform of Cn C1 U1 equal to plus C2 Vn equal to, you can take the constant term outside, C1 into Z transform of Un plus C2 into Z transform of Vn. So this is the first property, linearity property. So next one is the damping rule. These are very important. Just you need to remember damping rule. Damping rule. We are applying this while solving the problem. So damping rule is very important. So what is it? Let's discuss. Now suppose if we can write Z transform of Un as U bar of Z. Okay, suppose if we can write Z transform of Un, because when we find Z transform for function and suppose if the series converges, it will be a function of Z only. That's why we can write it as U bar of Z. Then according to damping rule, we have Z transform of Kn Un, that is equal to U bar of Z divided by K. Okay, second one, Z transform of K power minus N into Un, that is equal to U bar of K into Z. I hope you are able to see the difference between them. Z transform of k power n into un equal to u bar of z by k. Z transform of k power minus n into un is u bar of k into z. Okay. Suppose if the power of n is negative, then it is u bar of kz. Suppose if the power of k is positive, then it is u bar of z by k. Is it okay, everyone? Done? This is the second property, damping rule. Okay, so now we can prove that also. Let's discuss about that. Z transform of k power n into un. Let's apply the formula of Z transform. According to Z transform, we have n equal to 0 to infinity. Here the function is k power n into un. So it will be k power n into un into z power minus n. So this you can write it as un into. I'll write this as, say, summation n equal to 0 to infinity un into k by z whole power n. Okay, k by z whole power n. So this I can write it as u bar of z by, because if this series converges, it will be a function of z with, here we have some k term, that's why it will become u bar of z by k, because z transform of k power n into un. Therefore, you can consider z transform of k power n into un is u bar of z by k. Okay, then similarly, this is according to the formula of Z transforms. Now similarly, suppose if we have Z transform of k power minus n into un. Again apply the formula of Z transform. It is n equal to 0 to infinity k power minus n into un into z power minus n. So that is equal to, how it you can write it as summation n equal to 0 to infinity un into k z power minus n. So now compare this with your standard definition of z transform. Z transform of un is what? Summation n equal to 0 to infinity un into z power minus n. So in place of z we have kz. So this can be written as u bar of kz. So this is how it is proved. Z transform of k power n into u power n is u bar of z by k, as well as z transform of k power minus n into un is u bar of kz. This is very important rule which you need to remember. Now there are some standard applications of damping rule which we are going to study over here. Applications of damping rule. Applications of damping rule. Applications of damping rule. So let's discuss about it one by one. First one is, so we have discussed the damping rule. What is the damping rule? If zt, shall write first, if zt of un equal to u bar of z, then by damping rule first one we have zt of k power n into u power n un is u bar of k by, sorry, z by k. Z by k. And the second one says that Z transform of k power minus n into un is u bar of k into z. Okay, this is by damping rule. Now application of damping rule, here we have Z transform of k power n into n. What will be Z transform of k power n into n, where un is n over here. So in that case, what you need to do is, okay, in this case what you need to do is, let's write this as Z transform of n. Remember this, Z transform of n, where z approaches to z by k. Why I have written like this? See, Z transform of k power n into n is what? K power n into un is u bar of z by k. Am I correct? It is same as u bar of z by k. So Z transform of k power n into n can be written as Z transform of n, where z approaches to z by k, because Z transform of k power n into some function is u bar of z by k. So what we do here is, whenever you have z transform of k power n into n, you find the z transform of n where z you replace by z by k. This is what is the meaning of that. And we know z transform of n. What is the z transform of n? Here we have found out, isn't it? Z transform of n is z divided by z minus 1 whole square. Z transform of n is z divided by z minus 1 whole square, where z has to be replaced by z by k. I hope this is clear. Whenever you have z transform of k power n into n, find the z transform of n, and in that z you replaced by z by k, because k power z transform of k power n into un is u bar of z by k. So now when you replace z by k, what do you get? Z by k divided by z by k minus 1 whole square. So if you simplify this, z by k divided by z minus k divided by k whole square. So on simplification you get it here as, you can write this as zk, correct, kz kz, and this k and this k get cancels, 1k remains because k square is there, 1k get cancels, 1k remains, so it will be kz by z minus k whole square. So this is what, this is a z transform into n. Okay, is it okay everyone? Anybody any doubt in this? Is it okay? Are you able to understand? Megha, Kavya, Nandita,
Yes, ma'am.
Nikita?
Yes, ma'am.
Yes, ma'am.
Okay, now second one I'll discuss the same thing, z transform of k power n into n square. Okay, z transform of k power n into n square. Remember the first property of damping rule, z transform of k power n into un, that is equal to what? It is u bar of z by k. So whenever you have z transform of k power n into n square, what we need to do is we have to find z transform of n square where z has to be replaced by z by k. Okay, this is how you apply the damping rule. We know that k power n into un of z transform is u bar of z by k. So whenever you are asked to find z transform of k power n into n square, you find the z transform of n square and in that replace z by z minus k. What is z transform of n square? We have discussed just now. Z transform of n square is what? Anybody remember what is the z transform of n square? What is the z transform of n square? So these are the things you need to remember. That is z square plus z divided by z minus 1 whole cube. This is the z transform of n square. In this, z has to be replaced by z by k. Remember this. Z transform of n square is z square plus z divided by z minus 1 whole cube. Cube or square? What is it? It's cube, correct? It's cube, correct. Z minus 1 whole cube, where z approaches to z by k. Now replace z by k. What do we get? Z by k whole square plus z has to be replaced by z by k divided by here in the denominator as well, z by k minus 1 whole cube. So on simplification, what do we get? You can take the LCM. Here numerator z square by k square plus z by k, and here you have z minus k divided by k, z minus k whole cube, k cube. So if you take the LCM as k square over here, it will be z square plus kz divided by z minus k whole cube by k cube. So here one square get cancelled. So what remains is simplify and write it. It is z transform of k power n into n square, that is equal to k goes to the numerator. So we will have k into z square plus kz divided by z minus k whole cube. So this is nothing but k z square plus k square z divided by z minus k whole cube. So this is a z transform of k power n into n square. Anybody wants to ask anything? Anybody has any doubt? Anybody any doubt?
You are studying only infinite Fourier transform. In infinite Fourier transform, you study Fourier transform and inverse Fourier transform. Fourier cosine transform.
No? Okay. So next we will discuss about the same thing, z transform of k power n into n cube. So again we'll apply the concept of damping rule. Okay. According to z damping rule, z transform of k power n into un. K power n into un equal to what? It is nothing but u bar of z by k. So in order to find the z transform of k power n into n cube, what we do? We find the z transform of n cube. We will find the z transform of n cube, and in that z will be replaced by what? Z by k. Z will be replaced by z by k. What is z transform of n cube? We have derived just now. It is z cube plus 4z square plus z divided by z minus 1 whole power 4, and in that z has to be replaced by z by k. So this is the simplification we need to. It will be z by k whole cube plus 4 into z by k whole square plus z is replaced by z by k. In the denominator, z by k minus 1 whole power 4. So you simplify it. If I take k cube as the LCM, it will be z cube plus 4kz square plus kz. Am I correct? K cube, it will be k square, it will be k, correct? K square is the denominator, and this will be k square. So here in the denominator we have z minus 1, z minus k power 4 divided by k power 4. So here it get cancels, and just check what remains. Z transform of k power n into n cube. This is nothing but kz cube. Here one k remains, which goes to the numerator. So it will become kz cube plus 4k square z square plus k cube into z divided by z minus k whole power 4. So this is the z transform of n cube. Is it okay, everyone? Anybody has any doubt? Please ask. If you have any doubt, please ask.
We can have this
No doubt? Okay, so let's stop here for today, and I would like to briefly recall what are the things we have discussed in today's class. So you can compare this with the Laplace transforms. Okay, and from the basic definition of Laplace transform and Fourier transform, we have a definite integral which involved with the two parameters. But in Z transforms, we will have an integral which results in a, we will have the sequences of functions of a single variable, and it deals with only for non-negative values of the variable. And Z is defined for only the positive values, non-negative values, and it is defined as Z transform of un equal to summation n equal to 0 to infinity un z power minus n. And suppose if this converges, it will be a function of z only. We will get a function of z only. That's why this can be represented as u bar of z. Okay, u bar of z. Then we have discussed about some standard Z transforms. We have one property, that is Z transform of n power k. Z transform of n power k is minus z into d by dz of Z transform of n power k minus 1, where k is a positive integer. We have discussed about standard Z transforms. Standard Z transforms. What are the standard Z transforms? First one is Z transform of k power n. Z transform of k power n is z divided by z minus k. Okay. Second one is Z transform of 1. Z transform of n1 is Z by Z minus 1. Okay. Z transform of k power n is what? Z by Z minus k. Z transform of k power n is Z by Z minus k. Z transform of 1 is Z by Z minus 1. Then third standard Z transform. Z transform of n. Z transform of n is Z by Z minus 1 whole square. Fourth one. Z transform of n square is Z square plus Z divided by Z minus 1 whole cube. Then next fifth one. Z transform of n cube, that is nothing but Z cube plus 4Z square plus Z divided by Z minus 1 whole power 4. Okay, so this is the standard Z transforms. First one is Z transform of k power n is Z minus k. 1 Z whole cube. Then Z transform of n cube is Z cube plus 4Z square plus Z into divided by Z minus 1 whole power 4. These are the things you remember. Then also we need to remember this damping rule. Damping rule. What is the damping rule? Z transform of k power n into un equal to u bar of z by k. Z transform of k power minus n into un is, that is nothing but u bar of k z. So these are the damping rule, and using this damping rule we have proved some things. They are Z transform of k power n into n. This is nothing but kz by z minus 1 whole square. Then we have proved Z transform of k power n into n square, which is nothing but kz square plus k square z divided by z minus k whole cube. See, you can compare this with this as well. Z transform of n is z by z minus 1 whole square. So Z transform of k power n, see, I'll write over here. Z transform of n is z by z minus 1 whole square. So what will be Z transform of k power n into n? You just have to multiply by k. That will be kz by z minus k whole square. This is k, not 1. This is k. Z by Z minus 1 whole square. Similarly, when you have Z transform of k power n into n square, try to remember what is Z transform of n square. What is Z transform of n square? It is Z square plus Z divided by Z minus 1 whole cube. So Z transform of k power n into n square multiplied by k. So it will be kz square plus k square z. Some modification is there, divided by z minus k whole cube. Some modifications are there, but still you can remember this way. Then again we have Z transform of n cube. What is Z transform of n cube? It is z cube plus 4z square plus z divided by z minus 1 whole power 4. So what will be Z transform of k power n into n cube? It will be, see, some modification will be there. Kz cube plus square z square plus k cube into z. So you can go on increasing k values. K square k cube divided by z minus k whole power 4. This is how you can remember this. Remembering this also is important. Remembering these damping rules and their applications are also important. These are required while solving the difference equation as well as the questions based on Z transform. For now, you all need to study this and come tomorrow so that it will be easier for us. Standard Z transform, damping rule, and applications of damping rule. Is it okay, everyone? Anybody has any doubt, please contact me. Okay? Anybody has any doubt, you can even ask now. Is there anyone who has any doubt? Any doubt, anybody?
Plus infinity, e raised to I as
No?
e.
No doubt?
Now the limit is
Are you sure?
I'll go back to this particular. Now you can see that
No doubt?
we take here minus.
Shall we wind up today's class then?
Minus infinity plus infinity. Now how to split this?
Is it okay?
I can split this input as minus infinity.
Is it okay, everyone? Rohit, Sannidhi, Prajwal,
Plus.
Megha, anybody, any doubt?
For integration, I can.
Basavaraj.
No doubt.
Okay. Okay, done. Let's meet in next class. Thank you, everyone.
Plus.